Welcome back to our panel discussion, Computer Vision, Expanding Tomorrow's Mission-Critical Applications Today, sponsored by Dell Technologies on Federal News Radio, part of the Federal News Network. My guests today are Jeff Alstott, Program Manager at IARPA, Chris Algier, Federal Director of FirstNet, Stephen Dennis is Director of the Data Analytics Technology Center at the DHS Science and Technology Directorate. Michael Knight is Global CTO for the Industry IoT and Edge Business Unit at Dell Technologies. And John Garofalo, Senior Advisor for Programs in the Information Technology Laboratory at the National Institute of Standards and Technology. I'm your moderator, Tom Temin. And let's get to the questions we were getting into before the break. And I want to talk about some of the applications and use cases, some of the specifics where we're seeing this idea of Internet of Things overlaid with digital, mostly video, but also audio types of data streams. And Stephen, why don't we start with you at Homeland Security?
Certainly, and so we have many application areas, and I think we could do an entire segment on the use cases of Homeland Security. But I think to focus in, we would talk about emergency response and what does it mean for the future of smart cities and our ability for our emergency responders to come to the scene of an accident or an incident. How do we best prepare them? How do we keep them from being distracted? How do we keep them focused on the response so that they arrive ready to go, and the entire command structure of the emergency responder. And then also for disaster response, you can think about all of the different parties that have to come together around a disaster, sharing information, understanding where people are, making decisions in short time frames about where to deliver water, where to best put up aid centers. Those kind of things can be directly affected by this kind of work. Another application area where we've been working together with the infrastructure protection community, so the critical infrastructure folks, 80% of which are in the private sector, all would like to benefit from the security mechanisms brought about by the future of the Internet of Things, the sensors, the video cameras, the technologies. And we have worked with those sectors, and especially along the lines of national critical functions that have been defined by CISA at DHS, how to best understand what technical solutions are going to meet their needs and how to best manage those.
And Chris, I think in the FirstNet context, that's where a lot of that comes together, because especially in a major disaster or law enforcement situation, you would have multiple levels of government in many cases responding.
Right, and so making sure that trying to, actually let's back up a little bit and say, trying to assist public safety organizations in understanding sort of where broadband takes them, right, and where this information age kind of comes to. We have a lot of discussions about, well, smart cities, so what does that mean to an urban fire department, and what kind of information can they gather in order to better inform and perform? And so whether that's traffic data, right, so they're able to actually move a piece of fire apparatus more rapidly through the city because it understands the traffic conditions and things like that. And IoT is a big piece of that as well, where we have representatives from FirstNet are involved with the communities that are developing the building codes on how a building should be able to sort of take on that broadband capability in order to inform firefighters so they don't lose that information once they enter into a structure, where today oftentimes that may happen to them. And so how do you maintain the connectivity? But then again, in the use cases that we're seeing right now, just in the beginning from a video perspective, is taking things like license plate readers, just sort of driving along and consuming that information, but how some public safety organizations are using that for accountability purposes. We have a town in North Carolina, lots of tourists going out there during hurricane season. So how do we know how many cars entered out onto the area and how many have evacuated? And so using those license plate scanners to really help understand who's out there and to go find those maybe that are lost or haven't been able to get themselves out of a situation that may become more dire.
Yeah, so in other words, our modern infrastructures are really all networks encased in blacktop or concrete.
Oftentimes, yeah. So trying to push that out to the edge, again, being able to take that computing with you outside of an urban environment or suburban environment becomes pretty critical as well. We don't always get to choose where things happen. And so how do we make sure that the same type of capability and performance that's happening in a major urban area can also be transferred into a more rural or remote location just because the incident occurred there.
And what about the intelligence community, Jeff? What can you tell us about what are some of the applications and use cases you're looking at?
Yeah, so at IARPA, we partner with many different government agencies, and so DHS is certainly one of them. So everything that Stephen talked about would also be relevant. But we also talk with other groups such as law enforcement, such as the FBI. So we had the Boston Marathon bombing a few years ago, which was a great tragedy, and it was a tragedy on multiple fronts, amongst them being just the technical complexity of trying to rapidly figure out what was going on afterwards and then go find the bad guys, then be able to prosecute. And part of that was all the video footage that existed. There were many different private companies that happened to have security cameras that were pointed at the scene. And so the FBI needed to go get that security camera footage and then parse it very quickly, right? And so for us, the issue is how can you take thousands of hours of video camera footage, which might only span 1 hour worth of wall clock time, right? And quickly go through it in order to find if there are two people, say, wandering around and then abandon a package somewhere. And that's the sort of capability that we're really hoping to be able to deliver to law enforcement, not just for the real-time alerting paradigm, but also in the fast forensics paradigm, so then you can act.
Sure, I heard one FBI agent say that each new generation of technology brings an exponential growth in the amount of data they have to deal with on a per-case basis, which raises all kinds of questions about bandwidth and storage. And is that what NIST is partly looking at too, John?
So I think that's part of it. Part of it is being able to understand how to assess the performance of these technologies. So as we move more towards life-critical applications, which are needed in real time, like some of the ones that we've discussed, we need to understand how the user is going to interpret the information coming off of the analytic and be able to effectively understand when the analytic is misperforming, which there is no such thing as a perfect AI system, especially in computer vision. So training the end users to understand that these data streams is going to be critically important. Also, the other thing that I'm extremely excited about, going back to talking about the computational tapestry, is that a lot of the equipment manufacturers are getting very excited about the ability to bring AI to their devices. And so we see camera systems designed for security being enhanced with GPUs and CPUs. So they're actually becoming mobile computers. And we see lots of excitement in the GPU community, which traditionally focused on the gaming industry, now on AI and distributed AI. So this tapestry that's being created to support the kinds of applications we're talking about in public safety, ranging from being able to analyze large spaces with many different streams, to understand situation awareness, to be able to detect emergencies as they're happening, to be able to interact more effectively with the data and with people in communications. Very exciting opportunities, lots of complexity in how these are being developed, and measurement is putting up on my NIST flag. Measurement's incredibly important at all the aspects of these challenges, both in accuracy and in understanding failure and bias. So very, very important.
Jeff?
So on the topic of measurement of these things, so at IARPA, we are very serious about testing and evaluation. We often partner with NIST to evaluate the capabilities that we produce. And one of the great things about the artificial intelligence and machine learning paradigm is that it's possible to build testing in just a really efficient and smart way that then can communicate to stakeholders what is actually going on. So when you train a machine learning system, you take a whole bunch of data that you train on, and the AI is going to learn to do that perfectly. So that is uninteresting in terms of testing. But then you have some other data set, that's the test data set, that is from the same general distribution as your training data set, but it's separate. And then that's what you test your AI on, and that is the metric that describes performance. And so what's really nice is that you're able to iterate on AIs and see that test performance go up and up. So at IARPA, we have funded this thing called the Activities and Extended Video Leaderboard, which is actually run by NIST. And this is a active leaderboard that's constantly updating of researchers and private sector individuals that have been submitting their code, and it's running on NIST machines, and the NIST website can say, this is the best in breed for the activity detection in extended video. And that sort of paradigm is able to work across many different areas of machine learning. So this isn't a thing that we necessarily had in the past, of this really rapid iteration and communication of test performance. This is going to be particularly relevant if you're wanting to have a new paradigm, including just it's a new year. How do we see whether or not our algorithms work on a new data set? Well, you just bring in the new data set, plug it in the machines, and then start testing on that.
Michael, this seems like a pretty heavy technology load to take on.
Yeah, so I think there's a couple of very specific things that we've worked with, not only different agencies, but even local county governments and cities on, and to the point earlier, there's digital cities, there's smart cities, there's safe cities, right? And those are kind of different ways to approach all of that. But as we look at the safety aspect of that, I think the one critical thing is we know that things are going to change, right? Our models are going to change. One of the important things, John, again, coming back to you, again, it just seems like we have such a connection here. We made a comment about hurricanes and tourism and those types of things that get aligned. Well, the interesting thing is that in a normal tourism season, you might use something like a pedestrian counter because you only have a certain flow of people. Well, if there's some major event happening, you actually have to move to a crowd counting algorithm, which is completely different. Are our cities prepared to do that? Can they pivot that quickly? Can they use a consumption model? So one of the things that we focus on when we're working with cities and agencies is, do you have an architecture that you can quickly update or change the types of models that you need based on the situation so you can get the right information out? Because as I mentioned, if you're using a pedestrian counter on 600 people, it's going to give you completely wrong information, right? So you need to be able to change that. So it's the testing ahead of time. So we have significant surveillance and safety labs that we have. We also have IoT labs as well as partners such as Intel and NVIDIA that we work with to do performance testing to ensure that their platforms can handle certain things. And then we have to do those algorithm testings on there. And of course, test to fail, because just testing to succeed is pretty easy. Test to fail so you know what those situations are. And then most importantly, have an ongoing, whether that's a managed service or something like that, that ensures that these platforms not only stay healthy, but the model stays up to date. So we have to have the right reinforcement mechanisms for that too. So it's an architecture that can support that at the edge, core, and multi-cloud. And we have make sure that we can enable orchestration as a big part of that. That's key.
So it sounds like you need to test for both performance and also impact on mission.
I'd just like to follow up and say, when you're implementing systems like this for high consequence decision making, I think it's really important to have a robust set of test data that you're using to extrapolate, the risk of using that technology. For when you decide to implement that automation, you are incurring a risk, right? That there'll be some condition that you didn't think of before. And so in our testing in the past, we've actually tried out a lot of different situations where all of the parameters change, and you want to see how rapidly you can adapt one system to meet new and changing conditions. So I think it's really an important thing to understand, and there are a lot of policy implications as well as risk communications issues.
And also the curation of your test data sites becomes a really important activity.
That's right.
And this is exactly in line with what I want to talk about, and that is that I think a lot of people have talked about data is the currency of the future. And the challenge that we have in public safety in cities is making the data available that these cities have already existing for the development and testing of these kinds of complex algorithms. There's lots of challenges in terms of the policies for the use of these data and research, but also interoperability in the systems right now that are being used in public safety, very complex set of systems that don't talk well with one another. This is a huge challenge that we need to address. But in the end, we'll be most successful if we can create a set of tools so that public safety officials, folks in cities, can develop their own technology, their own computer vision algorithms using their own data and understand how to work with that data to curate it, to create the models and test them themselves, and how to adapt those systems as their environment changes. And so I think we'll be moving away from sort of these predefined, fixed kinds of tool packages that manufacturers are creating to sets of tools that allow the end users to create their own applications. That's the direction we're moving.
Chris?
Because I think one of the things you're going to find is, and we're seeing it today, is that same sensor, right, is gathering information, but depending upon the mission and the role of the consumer of that data, that can mean completely different things, right? So deploying a single sensor will actually result in probably a multitude of different actions based upon if it's, is it fire, is it EMS, is it law enforcement? So it's going to be interesting to see as those things continue to roll on, where organizations can come together and say, well, I don't need to deploy 5 or 6 different things. I can actually use one thing. It's just what's on the back end to make it understandable to me and shareable amongst my peers and within your own organization.
All right, on that note, we'll take a break before we come to our third and final segment, and a lot more to explore yet. I'm your moderator, Tom Temin. This panel discussion is Computer Vision, Expanding Tomorrow's Mission-Critical Capabilities Today, sponsored by Dell Technologies here on Federal News Radio, part of the Federal News Network.